Okay, this is another function with a restricted domain. Now this doesn't have a natural restriction to it. It's not a one-to-one function. If we look at this function 2 minus x squared, that's just going to be, if we look over and graph it over here, that's going to be the same thing as y equals negative x squared plus 2. So it's a parabola open downward, but shifted up 2 units. There's no horizontal shift, but a vertical shift of 2 units. So I go 2 units up, and then it's shaped like an N because it's got a negative in front of it. So it's flipped, so it's going to go down like this. So this is what this function would look like on this restricted domain of x is less than or equal to 0. So it's the left side. Remember, we've got two sides to this, but it wouldn't be a one-to-one function, so we couldn't take the inverse and get an inverse function unless we made it one-to-one, so this restriction does do it. So we have a design restriction on the domain. It's not intrinsic, it's just designed. So we can look at the domain over here, and this is going to help us find the domain and range of our inverse function. That's going to help. So the domain is going to go from negative infinity to 0. And the range is going to go from negative infinity down here all the way up to 2. That's going to be the domain and range of our function. So for our inverse function, which we're going to find out in a moment, we'll just write this over here, f inverse of x. These are flip, so my domain will be negative infinity to 2, and my range will be negative infinity to 0. Remember, the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So this is going to help us make any determinations on our inverse function. All right, so let's find the inverse by using our 4-step process. So step number 1, I'll call f of xy, so y equals 2 minus x squared. Step number 2, I'll reverse these, or interchange the x and y, so make this x equals 2 minus y squared. And I'll solve for y. So what I can do is, if I don't want to deal with a negative sign, I can put the y squared on the left and the x on the right. Or I can just add y squared to both sides, so I'll get x plus y squared equals 2. Then I can subtract x from both sides. This is solving for y, so I did one step over here. So I add y squared to both sides, and I'll subtract x from both sides. And this ends up being y squared equals 2 minus x. And then if I want to solve for y, I know that by my square rule, if something squared equals a quantity, then that something equals plus or minus the square root of the quantity. So y equals plus or minus the square root of 2 minus x. And then my 4th step, I guess I can do that over here, step number 4. This is going to be f inverse of x. So that will equal, now we've got plus or minus, so this is not going to be one-to-one, so I'll just write it without the plus or minus, and I'll determine whether it's positive or negative in just a moment. So it's going to be plus or minus 2 minus x. Now if I want to graph this, we would have to shift it around. Remember, when we have these, we have to have it in the graphing friendly form, so what we would have to do is call this y. It's going to be the same thing, just it's going to be easier to graph. The square root of negative x plus 2, and then remember we'll factor out a negative sign, so we get it in that form that we need. It's going to be minus, it's going to be the square root of negative quantity x minus 2, so that's going to give me my shift. So I'm going to be shifted 2 to the 2 to the right again, but it's going to be, instead of, remember, the right eyebrow, it's going to be flipped, so it's going to be the left eyebrow. It's going to be flipped to the symmetrical to the y-axis. Okay, so when we graph it, this is what we're going to have. Okay, but remember, it's still going to have a plus or minus. So we have to graph the plus or minus and then decide what we're going to use. So let's go over here. So I'll write my original function like this, or my original inverse function in this form. But I'm going to actually graph this one over here. So what's that going to look like? So we have to go back to our parent function, so hopefully you remember how to do your parent functions. So this is going to have a shift of 2 to the right. And it's going to go, plus will be on the top, and it's going to go to the left because it's got this negative, so it's flipped relative to the horizontal axis, so it's going to go like this. 1 up 2, or back 1 up 2, and back 1, 2, 3, 4 up 1, 2, like that. Square root of 4 is 2, so it's going to go like this. That's going to be the positive, and the negative would go down like this. On over, down to, let's see, 1, 2, 3, 4, down 2. So this is really what we've got when we took our square root down here and we had plus or minus. Because you have to consider that plus or minus. You just can't take the positive or the negative. You have to consider both. So now we've got 2 branches for this inverse that we took. But we wanted it to be a 1-to-1 because our original function was 1-to-1. So the inverse must be 1-to-1. So we have to decide which branch we're going to use. Now if I look at the domain, now remember I got my domain and range from my inverse function from the original function by flipping them. So the domain is negative, my inverse function is negative infinity to 2, and both these branches have a domain of negative infinity to 2, negative infinity to 2. But which one has a range of negative infinity to 0? The bottom branch. So I'm not going to use the top branch, I'm going to use the bottom branch, so I'll just cross this one out. And that's going to be my inverse function. So now I have to say that that's going to be the negative, so I've got to go back and say I'm going to use the negative, or the negative of the square root. So I go back over here, and I know that now my inverse function has got to be not the positive, but the negative. And you do have problems like this in calculus A, B, where you're solving differential equations, and you may end up with a positive or negative, and you have to go back and look on restrictions of the original domain to figure those things out. So this is a technique that we'll see again in calculus. Okay? So now if we graph both these on the same axes to check for symmetries. This is my original f of x. Goes something like that. So that's f. You should mark these f and f inverse. And then f inverse goes like this. Down 1, 2, or 1, 2, 3, 4. Oh, they both go to the same point, don't they? That's interesting. And there you go. And then if you check that with your line y equals x, so the line y equals x, you can see your nice symmetries there, both symmetrical to that line. So everything checks out. So this helps us determine which branch we're going to be using. Okay, so you have to go back and, again, use all these concepts about inverse functions, which are very important, especially when we get into the trig inverse functions. We'll be using these a lot. Okay? So I hope that all makes sense.